It is said that in an infinite universe, anything that can happen not only will happen, but has happened an infinite number of times. In such a universe, the idea of intelligent life out in the vast depths of space, other than humanity, is a guarantee. But if such life is a guarantee, what would it be like? How would such life have evolved? And how would it interact with other intelligent life? To answer that, we'll need a place to do some tests. Welcome to the galaxy of Galapagos, a barred spiral galaxy that lies just beyond the visible barrier of the universe from Earth, home to some 100 million stars that, in a remarkable cosmic coincidence, all happen to form at the exact same time. In our search for intelligent life, we need to focus on where life can develop, and for the sake of this series, we'll only be focusing on carbon-based life, as it makes everything far easier when you actually have an idea of what systems are likely to be at play. Too close to the galactic core, and the density of stars will irradiate any world beyond the potential for life as we know it. And if we go too far from the galactic core, there won't be a high enough concentration of elements to form life. So, we shall focus on stars that sit within the galactic Goldilocks zone. Next, since all these stars originated at the same time, there are only main sequence stars to worry about. However, even then there are a few main sequence stars that we can continue to ignore for now. O, B, and A-class stars are so short-lived that any planets that orbit them have barely enough time to cool to form liquid water, let alone begin to develop life. On the opposite side, M-class stars would require a habitable planet to orbit so close that the star's own radiation may be enough to cause issues for life. So for now, we'll only consider F, G, and K-class stars suitable for life. As it happens, in the Amazon sector, there is a G-class star of similar mass to Sol, with a planet orbiting at 1 AU of a similar mass to Earth, which happens to have a satellite of similar mass and distance to the Moon. Given the clear similarities, it is an exceptional place to start our exploration into the development of life. The first thing to note is that the first 300 million years are going to be chaos. After the initial formation of the star, which we will name Sekun, a solar wind will begin to clear the loose debris of space dust from the system. What is left behind are the planetoids that will eventually collide and form the planets of this system. There are 10 orbits with enough debris to be capable of filling these planets, 6 rocky planets, and 4 gas giants. However, due to the nature of resonant orbits, the debris that would have formed the 6th planet instead is further spread out by the gravity of the first gas giant. As a note, I suspect that any planet that would form between a 1 to 2 and a 1 to 3 orbital resonance with the first gas giant in a system will not be able to form due to the frequent gravitational tugging, thus forming an asteroid belt with maybe only a planetoid or dwarf planet that is able to form. Anyway, as the planets gather mass, they will steadily sweep their orbits clear of debris and other planetoids, colliding until only one planet remains per orbital path. It is likely that during this period is when the planet's moon is formed. Now we have a planet sitting nicely in the habitable zone. We shall name it Eden. As Eden clears its orbit of smaller planetoids and asteroids, it will cool, forming a solid surface, and slowly begin the internal convection currents that will soon form the plate tectonics of this world. After about 300 million years, Eden's surface has cooled to below 100 degrees Celsius, and the first rain will fall. Oceans will develop, and as compounds and elements dissolve into the water, the perfect environment for life will develop. At this point, the initial hydrogen-helium atmosphere will have dispersed, leaving a thick, heavy smog of volcanic gases, predominantly carbon dioxide. It should be noted that the exact origin of life is still unknown to scientists, but we'll save the true exploration for life for the next episode. Until then.